Again, welcome to data mining course. Again, in these lectures, we're going to discuss about classification algorithms, the definition, and also the concept. In our previous lectures, we went through what is data mining and the four basic tasks of data mining. And one of them is classification. We also have cross-story, association, and also anomaly detection. In these lectures, we will go details about classification algorithms. So again, this is our lecture unit 4, part 1. And these lectures cover our textbook, chapter 3. So first, classification, the definition here. We said normally classification, we have 2 steps to follow. The first step is to train our model. The second step, again, is to test the model. So first, we said that given a collection of records, which is our training set, as we discussed earlier, again, a training set is a data set with a target variable. So for example, if I have a data set about patients that have breast cancer and don't have breast cancer, my training set also should include the results. Maybe we have the patient name, the tumor size, the tumor types, etc. We're also going to have the target variable, which is whether the patient have cancer, yes or no, true or false. So a training set is including all the attributes and also including the target variable, the result we want. So each record contains a set of attributes, and one of the attributes is the class. That's the result. So if I want to know whether a taxpayer cheats on his tax returns, my class or the target variable or the class will be whether the taxpayer cheats, yes or no, true or false, whether he cheats or not. Whether a patient have a cancer, yes or no, true or false. So a training set always, with all the attributes, also include the result, the answer, which in this case we call the class. So if we have the training set, we can find a model for the class attributes as a function of all the values of other attributes. So since we have the training set with all the set of attributes about any entity, whether patient, customers, etc., we also have what we are looking for, the results. So we are going to use the training set to build our model. Then later we have the test set. The test set also will contain all the set of attributes, but excluding the class. So this is where we want the model to make the decision for us. So if I have a data set with patients that have a disease A, my training set will include the previous patients that have that disease A. We have all the attributes of that patient and also the class label. We are going to use the training set to build a model. Next time I may have a patient, we don't know whether I have disease A or not, but we took all the values of all the attributes. Now we are going to run this data in the model and see what decision the model will give to us. So we say a test set is used to determine the accuracy of the model. Usually the given data set is divided into training and test set, with training set which is used to build a model and the test set is used to validate it. So classification versus prediction. Now the difference between the two is our class labels and the data types. So here classification will predict categorical class labels. What we mean by categorical will be example of patients with disease A. Our class label is true, false, yes, and no. This is a discrete or nominal data, level of measurement, the data. So if, for example, I want to predict employee salary in the future, salary is a quantitative data or continuous data. So that will be a prediction. Classification, the class label is discrete or nominal. which is yes, no, true, false. Prediction, the class label will be a value, continuous value. Like, for example, here we have a credit approval. Credit approval will be based on your credit score or your income. These are all values. So again, classification predicts categorical class levels, which is the discrete or nominal, and it will classify the data based on the training set and also the values. The values are the class labels in the classifying attribute and uses it in classify the new data. Prediction is based on continuous value function, so it's quantitative, and it will predict unknown or missing values. So typical examples would be credit approval system. Again, here it's using quantitative data, targeting marketing, medical diagnosis, and fraud detection. So again, prediction models and continuous value functions. So example would be support vector machine neural networking. This is a function. Or regression analysis. This is an equation, mathematical function. But with classification, example will be decision trees. Decision tree, we can model it in a way that we may have true, false, yes, no, etc. So we say classification is two steps process. The first step is the model constructions, which will describe a set of predetermined classes. So each tuple or record or sample is assumed to belong to a predefined class as determined by the class label attribute. So what we mean here is that again I have a patient, 10,000 patient data set, and they all have disease A. So my class label will be that this is A column, yes or no. Then the rest of the attributes can be the patient's temperature, weight, other possible attributes. Other possible attribute that we know is relevant to the disease A, whether yes or no. So this will be our training set, as we said earlier. The set of tuples used for model construction is called a training set. Then the model is represented as classification rule. Example can be the decision tree or any mathematical formula like regression analysis or neural networking, which we will go detail on it in the future lectures. So the model usage here we say for classifying future or unknown objects. I can classify whether patients have a specific disease or no. Also, we can estimate the accuracy of the model. So a known level of test sample is compared with the classified result from the model. Accuracy rate is the percentage of test set sample that are correctly classified by the model. And also the test set is independent of the training set. Otherwise, we're going to have overfitting. Later, we're going to discuss what is overfitting, the concept. Also, if the accuracy is acceptable, we can use the model to classify the data tuples. So again, the concept of overfitting is that we may have a training data set, and this training data set, we are going to use it to build a model which we think is accurately good. But when we try with a test set or a future data to diagnose or to give us a solution, most the solution will be wrong. So which means with the training set we use to build a model, there may be a bias. Maybe it's too much, too less, or some attributes are missing, etc. So this is the process, the first process. We have a training set. In this case, we have a data set about professors' ranks and their name and number of years they are teaching. And we want to know whether they are tenured, yes or no. So our class target or the label will be the 10. This is what we want to predict. whether the professor is tenured or not tenured. So we have some of them yes, some of them no. So this is again classification. So the first thing we do, since we have a training set, we are going to load this training set into our classification algorithm. Let's say we are using decision tree. So we have the direction, we load it to our classification algorithm. And we build a classifier, which will be our model. Now, next time, the second step, which will be we build our model now, is to use the test set to test the model. So in the second step, we can see we have a data set here. By the tenor, we don't know whether it's yes or no. We don't know yet. So again, we are going to use our testing data without the tenor, and the system is going to, the model is going to again classify whether yes or no. So for example, here we have Jeff is a professor and he's been teaching for 4 years, but we don't know whether the tenor is yes or no. So since we use the training data to build a model, now we have classified, we are going to load our test set. And here the result came to be yes. Again, this result is given by the classifier. So what are the issues with classification algorithm? One of the main issues is the data preparation process. Because as we see, if the training set is not well prepared or the training set have error, then we are going to build a classifier or a model, classification model that have an error. So there's no way we can use that model to predict or to classify a good result or a good outcome. So data cleaning is very important. We need to, again, remove all the errors, which we normally call the noise. If there's any missing value, we need to get rid of it. If we need to do some data transformation to normalize the data, for example, we have two attributes, one value is 1, another value is 1 million. Now the difference between 1 and 1 million or 10 and 1 million is too big. So here we're going to do data transformation to normalize the data. Maybe the most common algorithm we can use will be the log normalization. For example, log base 10 of 10 will be 1. Log base 10 of 1 million will be 6. So we can see the difference between 6 and 1 are very close. So data cleaning is very important issue. So again, data cleaning is very important issue. Here we say pre-processed data in order to reduce the noise and also unlearn missing value. Then relevance analysis, which will be the feature selections. So for example, I'm trying to analyze a data set. In this case, I'm going to build a model. And also maybe, let's say this is a medical data set. So our goal is to predict whether patients have disease A or B or none. Well, one of the main features that I think will not be, it's not important, will be the patient's last name and first name. A patient's name will not determine whether the patients have a cancer or not, or disease A or not. But for example, address may depend, because there are some disease that, again, depends on where you live, geographical location. It also can determine your social economical status, So if geographical location can be important, we leave it. Last name is not important, we remove it. So that's the feature selection. We remove the irrelevant or redundant attributes. Any attribute that does not have any effect on the outcome, we remove it. Then we also go through what we call the data transformation. Here we are going to generalize and also normalize the data. Now, evaluating the classification method also is an issue. For example, the accuracy, predicting the class label, how accurate it is, guessing the value of a predicted attribute. So we need to, again, there's a process that we can use to, again, determine the accuracy of the classifier. And normally, the accuracy of the classifier will be the normal or the percentage of correctly classified records. Speed also is an issue. So time to construct the model, the training time, also time to use the model, classification or prediction time. Robustness, some of the classification algorithm again can handle can be very robustful, which means can handle errors. Even the data preparation, there's still errors in the data, it can be able to handle it. But there are some algorithms that cannot. For example, in classification, we can say decision tree is very prompt to handling noise and missing values. So the robustness is very small, less. But a neural networking algorithm can handle noise and missing values very well. So it's highly robustness. Scalability will depends on the size of the data. So here we say the efficiency in this resident database. Then interpretability. Can we be able to understand the results of the model or the classifier? For example, decision tree, very easy to understand. But neural network and everything is numbers. So it's difficult to understand comparing to decision trees. So other measures can be goodness of rules. Here we say such as decision tree size or compactness of classification rules. So illustrating the classification tags again, we have a different example here now. Here we have example, we can see our training set. Our goal is to know whether a person cheats in a task or not. So a taxpayer, the taxpayer ID is the first attribute. Second attribute, we have a third attribute, and fourth attribute. Let's say the fourth attribute will be an income. Third attribute, here we have large, medium, small, and yes or no. Then our class can be yes or no. So this is a training set again. We are going to load this training set into our classifier or the learning model. Then after that, we build our model. When we build our model, we use a test set. We consider the test set on the class last attribute, which is the class variable. It's a question mark. Now, it's up to the model now to give us the correct answer, whether yes or no. From the training set, the class is only two answers, either yes or no. So examples of classification tasks. Here, this will be in bioinformatics or computational biology, predicting tumor cells as benign or malignant, whether it's cancerous or non-cancerous, or classify credit card transaction as fraudulent or legitimate. Also classifying secondary structure of protein. We know protein have somewhere around 4 different types of structures, whether it's alpha helix, beta sheet, or random coil. This will be a classification algorithm because we may have a previous data. Based on the attribute set, we know whether it's alpha helix or beta sheet or random coil. So we build a model. So next time when we have a data set that we don't know the secondary structure, again, the system will give us based on the attributes. So classification techniques, first we will go through the decision tree based methods, which will be our next lectures. We also have the rule based methods. We also have the memory based reasoning, neural networking, which is one of the popular classification algorithm, which also leads us to deep learning. We may study deep learning also. Then we have the probability concept, naive, Bayesian belief network. Then we will go through support vector machine. Support vector machine with neural network is the same concept. They use functions, but again, different algorithms together. So let's go through an example of a decision tree. So now we have our data set, task ID, refund is two options, whether you get refund or not, so yes or no. Whether you are married, single, or divorced, or window. Then we have our taxable income. Now, our goal is that we have these four attributes here, and we know with these four attributes, we can determine whether the patient, and in this case, it will be taxpayers, whether the taxpayers cheat on their tax, yes or no. So here we have a training set, so we can see the result on the class label or the target variable. Is cheat, is yes or no. Now, the concept, we have the algorithm, which we will discuss later, to choose the right attribute or the attribute that we are going to split. We have some algorithms that we use. For example, will be the Gini index. We will go through what is Gini index. We will go through what is entropy, which depends on the impurity of the attribute values. So yes, let's say, for example, here we're able to select refund. And refund have two options, yes or no. So we have yes or no. Based on the data set, the algorithm tells us that if refund is yes, then there's no way you will cheat. This means when we look here, most yes are no. So yes is no here, another yes is no, yes is no. So all the yeses are no. That's why we end. So this will be our leave node, our final result. We are 100% sure when a taxpayer gets a refund, it does not cheat. So it's no. But if it didn't get a refund, we have some no is no, and some no can be yes. So because of that, we need to test it with other attributes. So if refund is no, and also the marital status is single or divorce, and taxable income is less than 80K, then you are not going to cheat. But if your taxable income is greater than 80K, then you're going to cheat. This is if you're single or divorced. But when you are married, you don't cheat. So that's the attribute. So we can say that from decision tree, we can generate the rule-based algorithm. So here we can say that if refund is yes, then cheat is no. If refund is no, and marital status is single or divorce, and taxable income is less than 80K, then it's no, you are not going to cheat. If your taxable income is greater than 80K, then you're going to cheat. And the last rule will be if refund is no, marital status means married, then cheat is no. So that's the first method. We can see the same data set we are using. This is the decision tree we build. Our root node starts with refund. Here we have the same problem, but the root node is marital status. So again, the same concept. If you are married, no, based on the data set here. Married is no, another married, no. So 100% if you are married is no, so no. But if you're single or divorced, you get refund, yes, then you are not going to cheat, no. If you didn't get refund, but your taxable income is greater than 80,000, which is big, the chance of cheating is high, yes. Otherwise, no. So here we are saying that there could be more than one tree that fits the same data. Depends on the attribute that we selected first. So again, we have our training set. We apply our decision tree algorithm. Since decision tree also is a classification algorithm, it's a two-steps process. We have our decision tree algorithm, or here tree induction algorithm. Then we have our training set. We build our model. Then we apply the test set to see how crazy the model is. So applying the model to test data. This is our test data. So this is the tree that we built previously. So refund is no. So you can see that we check refund is no. So if it's no, we are going to the right side. Marital status is married. So we go to married. So if it's married, we don't need to check the income. We go straight to our result. The result is no. So our answer will be assigned cheat to no. So again, refund is no. We go through the no section. Marital status is married. So we go to the married. If it's married, according to the decision tree, all of them are no. So we have our decision no. So again, we build a model, apply the test set, we get the results. So that will be the conclusion for our first lectures in our course textbook, chapter 3. We start with the concept of classification, the definition, and example. Our next lectures, we're going to discuss about decision tree classification algorithm, more details. So again, wish everybody the best and thank you.